Hello, welcome to your next lesson on Unit 3-4, Angles in Polygons. The very first thing that I'm going to talk to you about is I'm going to talk to you about a formula you'll need in this section, and that formula is n minus 2 multiplied by 180. What do you use this formula for? You use this formula to find the total number of degrees that all of the measure of the inside angles will be in a polygon when you add them. For example, a square. I think we know a square has 4 right angles, and if you add 90 plus 90 plus 90 plus 90, you get 360. Well, you could certainly use this formula, and the formula is n, which is the number of sides, which is a square, 4, minus 2, it's always minus 2, and you multiply that by 180. 4 minus 2 is 2, 2 times 180 is 360. Now if you had a pentagon, that's 5 sides. 1, 2, 3, 4, 5. It would be 5 minus 2 times 180. So that's basically how you do these polygon problems to start off with. So this example here, you have a 6-sided figure, 1, 2, 3, 4, 5, and a 6. And 6 sides minus 2 times 180 gives you 720. So usually there's going to be an algebra component too, and you need to solve for x and find either x or find the angle measure on each angle. This is not a regular polygon, regular meaning that all sides are the same and all angles are the same. But for something like this, all you would do is you'd calculate this 720 out, and then you would work this out by adding every single angle here. And if you look at this, let me move this off to the side, you have 120 plus 140, and you basically just add all of these little angles inside, and you're going to get a total of 720. Now, where does the 720 come from? It comes from using that original formula, 6 minus 2 times 180. So all you have to do is take all of your angles, add them, set it equal to 720, and then use your good old algebra to solve. Now this is example number 1, so I would like you to get it down in your notes. Basically, I guess the work you need is kind of like right here, so if you need to pause this, feel free. But here's the work and how you do this. If you take 120 and 140, 130, add them all up, you get 444. The x's all together, you get 3x, and then you just, subtract from both sides, divide by your 3, and that'll give you 92 degrees. That's what x is. So this would be 92 degrees, and if you wanted this angle measured, it'd be 92 plus 58, so on and so forth if you need to find the angles. But if you just need to find the x, once you get the x, you're done. So it's a pretty simple problem. I'm going to move on to the next slide. What about the exterior angles? Well, what is an exterior angle? An exterior angle is if I continued this side on the bottom here out parallel or horizontally like this, this angle is an exterior angle. Now if I did that for all of the sides, I'll give you one more example here. Here's a side continued. This makes an exterior angle also. So all of these exterior angles, if I add them up, this is the weird thing. You think that it would depend on the number of sides in a polygon, but it doesn't matter if you have a 6-sided figure or a 4-sided figure or a 10-sided figure or whatever. It's always going to be this magic number of 360 degrees. Now this is the exterior angle theorem, or the sum of the exterior angles, which is 360 degrees. Now if you have a square, it's 360. If you have a pentagon, it's 360. Now, why am I dividing here by the number of sides? Well, that depends on the question. So if you wanted to find each interior angle, and it's a regular polygon, that means that all of these sides are the same, you could then divide by the number of sides the polygon has. So in this case, there's 6. So each one of these little exterior angles right there will be 60 degrees. 360 divided by 6. This would be example number 2. Get the formula and get a little bit of work here, so in case if I ask you this in class or on a test, you know that you need 2 formulas here. The first one, n minus 2 times 180, and you know when to use that. And the second one is always 360, and if you're trying to find each angle, you divide by the number of sides in a regular polygon. Last thing I want to talk about is I want to talk about parallelograms. Now parallelograms relate to the last one of the last units you studied when you have two parallel lines cut by a transversal. So if you have that, you know that corresponding angles are the same, alternate interior angles are the same. So when you also know that these ones on the same side here, they are supplementary. So when I'm talking about a figure like this you don't have to get down, you just have to listen, and the next one I'll have you get down, is if I'm trying to find this side right here, here is your parallel side, because it's a parallelogram, here is your transversal. If this is 80, this one has to total 180, so it's 100. And the sides across from each other are also the same. So that's the properties you have in a parallelogram here. If this is 80 on this corner, this would be 80 on this corner. If this is 100 on this corner, then this would be 100 on that corner. So remember that for our next problem. Here's our next problem. I'm going to call this example number 3A and B. So this is B. Sometimes it's pretty simple. You have to know if you have sides across from each other or if you have sides next to each other. If they're next to each other like they are here, all you have to do is add them up and set them equal to 180. So the properties of a parallelogram say consecutive sides like this, consecutive means in order, are supplementary. So total 180. So you got 11x minus 10 equals, I'm sorry, 11x minus 10 plus 80, because you have to add them, and that equals 180. So you got 11x. 80 minus 10 is 70, equals 180. Minus 70, minus 70. You get 11x equals 180 minus 70 is 110. Divide by 11, x equals 10. So if x is 10, you can substitute that 10 in there if you want to find the angle, or if you just needed to find x, you would be done. Now for the second problem, I have two consecutive sides, but unfortunately there's not a number. So I'll set these up for you. For example, 3b. Actually, if you want to pause it, you probably could try and set it up yourself. What would you do? Well, here's the setup. 9x plus 15 plus the consecutive side, 6x plus 15, that equals 180. There are a bunch of properties with polygons, and in these cases, a specific polygon called a parallelogram, and these are how you set them up and solve them. Now, if I knew that this was x on this corner, then you would have opposite corners, and you could set 9x plus 15 equals to x, and then you could solve for x. So it kind of depends on if the corners are side by side or across from each other, how you set it up. I'm not going to finish this problem. The setup is perfectly fine. I'm sure you know your algebra and you can figure that out. That's all I got for you. Thanks for listening.